Today, let's start solving 2022 May June paper 42. 2022 May June paper 42. Let's start. Small smooth spheres A and B of equal radii of masses 5 kg and 3 kg respectively lie on a smooth horizontal plane. Okay, let's start making the diagram. Smooth horizontal plane. I guess this is about collision. Let's see. Small sphere A, small sphere B. Masses 5 kg, 3 kg respectively. Initially, B is at rest. Okay. So 0 meter per second. A is moving towards B with a speed of 8.5. So this is 8.5 meter per second. The spheres collide. Okay. So this is about collision. So this is before collision. Now collision will occur. And there will be a state called after collision. So let's draw everything. So this is during collision. This will be after collision. So now during collision, A will come here. A came here, B came here. A, B. And collision occurred. And after that, after collision, what will happen? The spheres collide, and after the collision and after the collision, there should be a comma here. A continues to move in the same direction, but with the quarter of speed of B. Okay. Very interesting question. That means A is right here and B is here. And after the collision, A will start to move in the same direction. But now what will happen? It is moving to the quarter of a speed of B. That means speed of A, let me write to B. Velocity of A will be 1/4 of the velocity of B. So for example, if after the collision, B starts to move at 4 meter per second, then A will move at 1 meter per second. That's what they mean to say here. So now, but we don't know the velocity of B. So let the velocity of B be x meter per second. So the velocity of A will be x upon 4 meter per second. Now we can equate initial momentum. I will just write simply Im. But in the exam paper, you'll have to write the entire thing initial momentum equals final momentum. Or you can also write total momentum before equals total momentum after. So initial momentum will be this mass of A into velocity of A. So mass of A is 5, velocity of A is 8.5. B will have no momentum because velocity of B is 0 initially. So mass of A is 5 into 8.5 is equal to, then collision occurs, mass of A is 5 kg, mass of B is 3 kg. So 5, this will be mass of A into velocity of A plus mass of B into velocity of B. So mass of A is 5 kg and the velocity of A is x by 4. So let me remove this kg. Mass of B is 3, velocity of B is x. So 5 into 8.5, I put that in my calculator. The answer is 42.5. So I guess this is our last step. 42.5 is equal to 5x upon 4 plus 3x. Therefore, 42.5 is equal to 5 upon 4 plus 3 will give me 4.25x. Now, I will divide this 42.5 upon 4.25. So, this is a multiple of 10. So, 42.5 upon 4.25 equals x. So, the velocity will be 10 meter per second. Now, what have they asked us? They have asked us to find the speed of B. And speed of B is x. And what we found right here is x. So x is the velocity of B. So this remains the same. If if they have asked for the velocity of A after the collision. So we know that x equals velocity of B, which is equal to 10 meter per second. Now velocity of A is velocity of B upon 4. So velocity of A would have been 10 by 4, which is 5 upon 2 meter per second. So just in case, I'm just telling you, if they would have asked the velocity of A, you should have done this. Next question. Find the loss of kinetic energy of the system due to the collision. So now how will we find the loss of kinetic energy? So the loss of Ke will be the initial value of kinetic energy minus the final value of kinetic energy. So what is the initial value of kinetic energy? Initially, only A is moving. So kinetic energy will only be considered for A because the formula for kinetic energy is half mv square. So if velocity of B is 0, the kinetic energy will also be 0. But A has velocity 8.5. So we'll consider that. Initial K is half into mass of A is 5. Velocity of A is 8.5 square. So if we put that in the calculator, we'll get some answer. We'll do that later. Now we found out the initial K. Now let's find out the final K. So the final K will be half into 5 into the velocity of B plus, the velocity of A, final velocity of A. That is this, x by 4 plus half into 3 into velocity of B we know is 10. So 10 square. So final velocity of A is 4, is velocity of B upon 4. So that will give me 10 by 4, which is 2.5 meter per second. So instead of velocity of A right here, I can write 2.5. So this will become 2.5 square. Now putting this in the calculator, my initial kinetic energy value will be 5 upon 2 into 8.5 square, which gives me 180.625 joule, and this will give me 3 into 50, which is 150 joule. So therefore, the loss in kinetic energy will be equal to 150 minus 180.625, which is 150 minus 180.625. So the answer is minus 30.625. And because they have asked for loss, negative means nothing but loss. So loss of kinetic energy, this final answer will be 30.625 joule. And that's how we end this question. Let's move to the second question. Coplanar forces of magnitude 60 Newton, 20 Newton, 16 Newton, and 14 Newton act at the point of the directions. Find the magnitude and direction, the resultant force. Very easy question. Full 6 marks are very scoring. So what first we have to do is, we need to realize that these 4 forces are acting. And what do they mean by resultant force? So if for example, one force is acting like this and the other force is acting like this. So we can say that the resultant of these two forces will act somewhere here. So that means instead of drawing these two arrows, I can only draw this one arrow, and that would mean the same thing. So by resultant force, what I mean is, instead of these 4 arrows, there should be only one arrow which symbolizes the same thing. Because for example, there is a carom board here. There is a striker, and if I hit the striker like this and this at the same time, for example, one hand I hit it like this and the other hand I hit it like this. So the carom striker will not move in 2 other directions. It will move in one direction only, which will be the center. So instead of hitting it in 2 directions, I can only hit it in one direction only. So this will be the resultant force. So similarly, I have to find the resultant force for these 4 forces. Now, how do we find that? What is the first step we do is we resolve all the forces in horizontal and vertical directions. Now, what do I mean by that? this 16 Newton force that will act in two directions. One, it will act in the left a little bit, and one it will act above. Now this arrow, I will shift it here. So it will look something like this. Perfect. And now let me redraw the diagram. So this diagram is a triangle which looks something like this. Yeah, perfect. So this is 50 degree. This is 50 degree. This is 90. And this force is 16 Newton. And now what we want to do is we want to find the force that is acting completely down vertically and completely to the left. So we can use trigonometry. This is the opposite side. This is the adjacent side. And this is the hypotenuse. So let me erase this. So now we can use trigonometry, sine. Sine equals opposite upon hypotenuse. So this will be x upon 16. Now this 16 will go up. So finally I'll be left with 16 sine 50 is equal to x. And the other is this one y. So I can use cos because that is the adjacent side. So cos 50 is equal to y upon 16. So again the 16 can go there. So we'll be left with 16 cos 50 equals y. So now we have 16 cos 60 is equal to y. Now x is the force that is acting downwards. So let me draw this downwards in purple color. So this is 16 sine 50 x. And what is this force to the left? That is y. And y is 16 cos 50. So this force to the left will be 16 cos 50. Now let me erase everything else. So now what do I mean by resolving forces? By resolving forces, I can cancel this out now because I have resolved it. So what that means is if one force of 16 Newton acts at 15-degree angle right here, that is equivalent to one force acting at 60 cos one force which is 60 cos 50 acting to the left and one force 16 sin 15 acting downwards. Not 15, sorry, 15. And this should be 16. 1 second. Let me rewrite it. So this force originally was 16 Newton. This was 50 degree. So that means 16 cos 50 and 16 sin 50 is equivalent to this force. The only difference is this is going in a single arrow and this is the combination of two arrows, but it will mean the same thing. So now I have resolved this. So similarly, now I will resolve the 20 Newton force because even that is acting at an angle. So now let me use a green pen. So this is a 20 Newton force that is acting downwards. So one force will act to the right and the other force will act down. So this downward arrow, I will shift it here and it will look something like this. Yes. So now let me erase all the extras. Yeah. And let me redraw this triangle now. So this triangle will look something like this. So this is 20 Newton acting at an angle of 60 degree. This is 90. Uh, let this be X and this be Y. So now this side will be opposite. This will be adjacent and this will be hypotenuse. So now let me erase the arrows. Now let's find X and Y. So Y is opposite and opposite means sine. So sine 60 will be Y upon 20. This 20 will go up, which will get 20 sine 60. Similarly, cos 60 is related to adjacent and the adjacent side is X. So it will give us X upon 20. This 20 will go up, which will give us 20 cos 60. Now let me erase this. So X is 20 cos 60 and that is acting to the right. So this will be 20 cos 60 and the force acting downwards Y will be 20 sine 60. This is 20 sine 60. Now we will shift this arrow again here. So it will look something like this. Downward arrow 20 sine 60. Yeah. And now we can even with the same logic remove this arrow. Now we have all the forces. Now the only thing remaining is to separate the horizontal and resultant horizontal and vertical forces. Now how will we do that? In order to do that, let me reduce my screen a little bit. Yeah. So horizontal forces and vertical forces. So what are the vertical forces here? Only 160 Newton force is acting upwards. So the vertical forces are 60 Newton acting upwards. Now which forces are acting downwards? 16 sine 50 is acting downwards. 20 sine 60 is acting downwards. So 16 sine 50 and 20 sine 60. And horizontal forces 14 Newton. 1 second. 14 Newton. Yeah. 14 Newton is acting horizontally. 16 cos 50 is acting horizontally. And 20 cos 60 is acting horizontally. So on the left, one force is 14 Newton. Another force is 16 cos 50. And one force is 20 cos 60. Now what we have to do is find the magnitude and direction of the resultant force. So in order to do that, first let's find out the resultant horizontal force. So resultant force horizontal will be, if we are taking the left side as positive, then we can write 14 plus 16 cos 50 minus 20 cos 60. And if we put this in the calculator, wait, let me rewrite it a little bit properly here. Minus 20, minus 20 cos 60 minus 20 cos 60. Yeah. So if I put this in the calculator, 14 plus 16 cos 50 minus 20 cos 60. The answer is 14.28 Newton. Similarly, the resultant vertical force will be equal to, if we take upward as positive, then 60 minus 16 sine 50 minus 20 sine 60. So 16 minus 16 sine 50 minus 20 sine 60. So the final answer is 30.423 Newton. That means now we are commenced to, let's move to the last step. Here we have taken left as positive. So and the answer we got is positive. So that means 14.28 Newton to the left, and here we have taken upside as positive. So that means 30.4, and this answer is positive. That means 30.423 Newton upward. So these are the final horizontal and vertical resultant forces. 14.28, and this is 90 degree. And now, how will we find out the resultant force? In order to find the resultant force, I will shift this arrow here. 30.423 Newton. Erasing everything. Now this arrow will become this arrow will become the resultant force, which is the answer. So we can simply use Pythagoras theorem. Resultant force square is equal to 30.423 square plus 14.28 square. Now this resultant square will cancel out. It will become root here. Putting this entire thing in the calculator, root of 30.423 square plus 14.28 square will give me 33.61 Newton. So now 33.61 Newton is the magnitude. And what about the direction? For direction, this is the direction theta. Wait, let me use another pen. This is the direction theta. So this is the opposite side. This is the adjacent side. So what we can use is tan. Why? Tan theta is equal to opposite upon adjacent, which is equal to 30.423 upon 14.28. Therefore, theta will be tan inverse of, now the simplification of this, I'll do it here only, 30.423 upon 14.28, which will give me 2.13. So tan inverse of 2.13, if put in the calculator, then the value of theta will be 64.85 degree. So the answer is 64.85 degree. So finally, the answer is 36.6 Newton and 64.9 degree. And that's how we end this question. Let's start with the third question. Two particles, A and B, of masses 2.4 kg and 1.2 kg respectively, are connected by a light inextensible string which passes over a fixed smooth pulley. Okay, so this question is a pulley question. Let's start solving. So this is particle A. This is particle B. A is held at a distance of 2.1 meter above the horizontal plane. Okay, so this is the horizontal plane. So the distance between the horizontal plane and A is 2.1 meter. And B is 1.5 meter above the plane. Okay, so I'll have to extend this a little bit. B is 1.5 meter above the plane. Yeah, this is done. This is done. Particles hang vertically and are released from rest. That means the initial velocity of both the particles is 0 meter per second. Now I have not written the mass 2.4 and 1.2. Let me write down that 2.4 kg, 1.2 kg, and this is B. This is also done. In the subsequent motion, A reaches the plane and does not rebound. Okay. So now let me tell you something very obvious. A has a mass of 2.4, B has a mass of 1.2. So where will the pulley fall? Obviously, the pulley will fall here because this mass is higher. If I tell you, I have a pulley, this mass is 50 kg, this mass is 5 kg. So obviously the pulley will fall down here, right? The pulley will fall in this direction. Same, this is 2.4 kg, and because 2.4 is greater than 1.2 in our mathematical world, then uh, the particle A will fall down and particle B will come up. Particle A will fall down and particle B will come up. So A reaches the plane and does not rebound. That means A will just stop here. Show that the tension in the string before, so the tension, if we have to label, tension will be upward in the upward direction. So tension in the string before A reaches the plane is 16 Newton, and find the magnitude and the acceleration. Okay. So now let's solve for A first. So forces on A. Now, because A is right here, the mass of A is 2.4 kg. So the weight exerted due to the mass will be mg, which is 2.4 into 10, which is 24 Newton. So this will be 24 Newton. Now let me erase this. And this is 1.2 kg. So similarly, this will also go down, but not a proper arrow. Not an arrow I like. So this will become 12 Newton. Now what more? Nothing more. So now forces on A will be, because this is moving downwards, so this will be considered positive, this T will be considered negative. So 24 minus T is the resultant force. And we also know the resultant force is mass into acceleration. Mass is 1.2, acceleration we don't know. So therefore, 1.2 A is equal to 24 minus T. This is our first equation. Now, we are done with forces on A. Let's start with forces on B. So forces on B. Now upward direction is positive because acceleration is upwards. So T will be positive and this will be negative. So T minus 12 is resultant force. Now we also know that resultant force is equal to mass into acceleration. So the mass is 1.2, acceleration we don't know. So instead of this F resultant, I can write 1.2A. So my second equation is T minus 12 is equal to 1.2A. I have two equations right here. 1 second, did I do some error? Yeah, in this A, for mass I have taken 1.2, but the mass of A is 2.4. So this was a silly error. Yeah. So now let's equate the first and second equations. First, I'll write everything together. So the first equation is 2.4A plus T. I took this T here is equal to 24. The second equation is, I will take this 1.2A there. So I'll get minus 1.2a. This t remains here and this 12 goes there. So minus 12 becomes plus 12. So now I can solve this. As you can see, this is a simultaneous equation because you have two variables. Now let me pull out my calculator. I'll go to mode, phi equation, and I'll select one. This is ax plus by plus c, the third option, the first option. So I'll click on one. So I'll get 2.4 t and 24 minus 1.2, 1 and 2. So the answer for A is 10 by 3 and T is 16. 10 by 3, 16. 10 by 3, 16. 10 by 3, 16. 10 by 3, 16. Now this A will be 10 by 3 and this T will be 16 Newton meter per second square. But what have they asked us? To find the tension in the string before A reaches the plane and find the magnitude of the acceleration of the particles. Yeah, we have done both and we have got our answer. Let's move to the next question. Find the greatest height of B above the plane. Okay. So now here A will move downwards and B will move upwards. So what they've asked us to find the height. So now one thing to realize is the distance traveled by A will be equal to distance traveled by B. Now what they have told us right here is in the subsequent motion A reaches the plane and does not rebound. And during that time B does not reach the pulley. Okay. So A will go down and A will reach here. A will move down, 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 and A will reach here. But B will reach somewhere here only. B will not touch the pulley. That's what they are telling us. So now let us further understand this diagram. So now what to do? First of all, let me make the diagram again. I'll make the diagram here itself. So initially what was happening was here is the no horizontal ground here. Horizontal ground will be here. This is the pulley. A is 2.1 meter above the ground. B is 1.5 meter above the ground. And now what happens is A reaches down and B comes here. So now what will be the height of B? So if A has traveled down 2.1 meter, so when B will travel up 2.1 meter. So that means this distance will be 1.5 plus 2.1, which is 3.6 meter. But does the answer end there? No. Why? Because B has acceleration of 10 upon 3 meter per second square, which we found out in the first answer. Now, if we do V square equals U square plus 2S, the particles had started from rest. That means initial velocity was 0 meter per second. They have, if you don't remember, they have written here. Where is it? Particles are released from rest. We have been mentioned here, U equals 0, U equals 0. That means here U equals 0. So we can use V square. This U will be 0 plus 2. Acceleration is 10 by 3 and distance traveled is 2.1 meter. Because earlier it was 1.5 and then further it went up 2.1 meter. So the total distance traveled by B was 2.1 meter. So this V square will become root if it goes to this side. This is root. So the value for V is 2 into 10 by 3. Root of 2 into 10 into 2.1 answer upon 3. So this is root 14, which is 3.74. But let it be root 14 meter per second. That means this particle B, when it has traveled from 1.5 meter, when it has traveled up 2.1 meter here, the velocity will be root 14 meter per second because it is accelerating. Now that A has stopped here, the new acceleration has become 0. The new acceleration has become 0. Now B will only go up till here to neglect this root 14. So if I tell you that a particle is projected up at root 14 meter per second, what will be the maximum height it will travel? So at maximum height, its velocity will be 0. The initial velocity we know is root 14, and the acceleration will be minus 10 meter per second square. What we need to find is the s. So we can use s equals ut v square u square 2s. Yes, we can use that. We can use v square u square 2as. So v square u square 2as, and v is 0, u is root 14, but root 14 square plus 2 is minus 10. Displacement we will find out here now. So this will go there. So minus root 14 the whole square upon 2 into 10 is equal to s. Therefore, the distance traveled will be 14 upon 20, which is 7 by 10. So distance traveled is 0.7 meter. So that means after reaching 2.1 meter, after it has gained root 14, because of the velocity upwards, it will still move upwards a little bit, and that height from year to year will be 0.7 meter. So now, therefore, total no the greatest height reached. Because that's what they have find the greatest height. So earlier it was 1.5. We'll write that. So from 1.5, because A went down 2.1, this went up 2.1. So then again plus 2.1. And now because it was accelerating, because A was moving down with a higher weight, it gained a velocity of root 14 when it traveled 2.1 meter per. And because of that velocity, it moved up additional 0.7 meter. So we'll write that also. Now if I put this in the calculator, 1.5 plus 2.1 plus 0.7. Let me put that in my calculator. 1.5 plus 2.1 plus 0.7. So the answer is 4.3 meter. So that means the greatest height it has reached up is 4.3 meter. So that means this height right here, from year to year, this height is 4.3, which is the addition of 1.5 plus 2.1 plus 0.7. Now let's move to the fourth question. Particle A moving along a straight horizontal track. Let us make the straight horizontal track with a constant speed of 8 meter per second. Now there are two things to find out here. 1 second, what is happening? Why is my Microsoft Edge lagging? My cursor is not moving. You will have to wait for two seconds, I guess. Yeah, I'm back. So particle A is traveling along a horizontal track. Let me draw a bigger horizontal track. The particle A is traveling at a constant speed of 8 meter per second. Let me draw it a little bit smaller. Four seconds later, passes a fixed point O. Okay, that means here, let me draw a horizontal track here. This particle A passes the fixed point O. Let me use another pen. Make the diagram a little more visualizable. Yeah. 4 seconds later, another particle B passes O. Okay. So that means let this be the first diagram. Now, 1 second. Let this be the first diagram. Now in the second diagram, what will happen is here is O right here. O remains right here. But what happens is now because A is traveling to the right, A might have traveled some distance. We will find that out in a while. A is still traveling at a constant speed, but this is happening 4 seconds later. That some other particle B has also started traveling and it has reached point O. Another particle B passes O 4 seconds later, moving in the same direction. Okay, so this speed is also in the same direction. Particle B has a speed 20 meter per second. Okay, so the initial speed is 20 meter per second. When it passes O, and it also has constant deceleration. So constant deceleration means the acceleration will be minus 2 meter per second square. B comes to rest when it returns to O. Okay, that means the final velocity of B when the displacement is 0. The velocity will be 0. Why? Because displacement starts from this point 0. When it will return to it, what is displacement exactly? If I tell you this is origin O and I have traveled 50 meters ahead, I came 20 meters behind. So my displacement will be how far away I am from the original position. So I will be 30 meter away. This my displacement will be 30 meter. But my distance traveled will be 50 plus 20, which is 70 meter. So that is the difference between distance and displacement. So right here by S, I have written displacement because they have told that when B comes to rest, B comes to rest when it returns to O. When it returns to its displacement will be 0 and it comes to rest means its velocity will be 0. Now find an expression in terms of T. Now first let's find out how much distance has A traveled in this 4 seconds. So we can use distance equals velocity into time. So velocity was 8 constant, time was 4, which is 32 meter. So this distance right here is 32 meter. Now what else? Find expressions in terms of T for displacement from O of each particle T seconds after B passes O. So T seconds after B passes O. So after B passes O, the displacement of A, how will we write the displacement of A? The displacement of A is velocity into time, which is 8t. But now, if you write t as 0, so the displacement of A will be 0. So 8 into 0 is 0. Why have I written 4? I have no idea at all. So 8 into 0 is 0. But now, is this true? That displacement from O of each particle t seconds after B passes O. So after B passes O, it has already traveled an additional 32 meter. So you'll also have to write plus 32. So in short, the distance traveled by A will be not only be Vt, which is velocity into time. The displacement will be velocity into time plus 32, which is 80 plus 32. And so here, the distance traveled by A will be 32 plus 8t. Now let's talk about distance traveled by B. So the distance traveled by B, first of all, we have to realize that for B, there is a deceleration of minus 2 meter per second square. The initial velocity is 20 meter per second. So now we can use this equation, displacement of B is equal to ut plus half at square. So displacement of B, initial velocity is 20t plus half acceleration is minus 2t square So displacement of B will be 20t minus t square. So this is our equation for the displacement of B. Now the question they have asked us to find the expressions in terms of t for displacement of O for each particle. So this is for A, this is for B. And so we are done with this question. All the next B question. Find the values of t when the particles are the same distance from O. That means the displacement of A should be equal to the displacement of B. That's when they have traveled the same distance. So what is the displacement for A? 32 plus 80. 32 plus 80 is equal to displacement of B is 20 minus t square. Therefore, this can go there. This can go there. So minus t square will become t square. 80 will remain 80. 32 will remain 32 plus 20 will become minus 20. Therefore, t square plus 80 plus 12 is equal to 0. Now I can put this in the calculator. Mode setup. You select the equation, which is phi eqn. Then ax square plus bx plus c, which is the third option. So 1, 8, and 12. So my answer is -2 and -6. But I think then something will be wrong here. Because time cannot be negative. So 1 second. If this is incorrect, 20t minus t square. Yeah, here it is written 20t, but I've written 20 here. So silly error caught. So 20t minus t square. So this will become minus 20t. So 8t minus 20t will become minus 12t. So minus 12t plus 32. Now again putting this in the calculator. 1 minus 12, 32. The answer is 8 and 4. That means the particles are the same distance from A. Other time is 8 and the time is 4. So this is our answer. On the given axis, sketch the displacement time graph for both particles from the values t equals 0 to t equals 20. Okay. So now we know it is this is very easy for A because A is 32 plus 80. So when time is 0, A will be 32. Why? Because when t equals 0, displacement of A will be equal to 32 plus 80, which is 32. Because 32 is the y-intercept. Similarly, this is nothing but a equation of a straight line, ax plus b. So this will be a straight line and it will end at 20. So displacement of A at t equals 20 will be 32 plus 8 into 20. So 32 plus 160, which is 192. So 192 will be somewhere here. So let me erase everything. This is so time consuming. 192. Yeah. So at 20, around somewhere here, this will be 192. And this is a straight line. So this is displacement of A. Now talking about displacement of B. So now we know that uh, now we know that when particle B comes to rest, when it returns to O. So that means at some point particle B will return to O. So initially, what is the displacement of B? It is 20t minus t square. So when will the displacement be 0? So it will be 0 at 20t minus t square. So 0 equals t, 20 minus t. Therefore, t equals 0 and 20 minus t equals 0. So t will be equal to 20 seconds. So that means displacement B is equal to 0 when time is 0 and time is 20. So when time is 20 and time is 0, displacement will be equal to 0. Now that we are clear with this, let's move ahead. Now what we will have to find is the maximum point on the graph, because we know that this will be a quadratic equation and the quadratic equation will have a curve. So what will be the maximum point of the curve? Will the curve be something like this, or will the curve be something like this, or will the curve be something like this? How exactly? In order to find that, what we'll have to do is we'll have to find the maximum point of the graph. So in order to find a maximum or minimum point of a graph, what we do is we derivate the equation. So let's derivate 20t minus t square. So this will give us 20 minus 2t, and we'll equate this to 0 because the gradient of the graph, derivation means finding the gradient, finding m. M is gradient. So the gradient of any gradient at the maximum point is always 0. Why? Because take this. This is a maximum point. So if we draw a gradient, the gradient will be a straight line. So gradient is 0 at the maximum point. So equating this to 0. So this will also be 0. So t will be equal to 10. And at 10 second, what will be the displacement? So displacement of B will be 20 bracket 10 minus 10 square. So 20 to 10 is 200 minus 10 square is minus 100, and this is equal to 100 meter. So that means at time 10 second, the displacement will be 100 meter. So at time 10 second, displacement 100 meter. Uh, yeah, so the graph is somewhere here. Let me check. For displacement of A equals 32 plus 80. So 32 plus 8 into 100. Oh no, T is 10. 1 second. T is 10. So 32 plus 80 equals 112. So that means this point of displacement of A is 112. That means displacement of B will be somewhere down only. So this graph will look something like this. Yeah. So this is what the graph will look like. What I did right here was I founded the distance traveled by A when uh, when the time is 10 seconds. So it was above. If this was equal to 100, then both would have touched here. And if this was less than 100, then this would have gone above this like this. But displacement of A was higher, so the graph do not touch. And that's how we are done with question 4. Let's start for solving the fifth question. A block of mass 12 kg. Okay, so that is not mentioned here. So the mass is 12 kg. And because the mass is 12 kg, we can also write weight equals mass into gravity. Mass is 12, gravity is 10. So the weight due to the mass is 120 Newton. So the weight acts 120 Newton downwards. So now let me erase this. Yeah. and inclined at an angle of 24 degree, that is mentioned in the diagram. A string of a light string makes an angle of 36 degree. Okay, above the line attached, the tension between the string is 65 Newton, that is mentioned. The coefficient of friction between the plane is U. That's what you have to find out, the coefficient of friction. The block is in limiting equilibrium. Okay, so this is a new statement. The block is in equilibrium, and that means the resultant force on the object is zero. That means there are no net resultant forces on the object. That's what we need to understand. And is on the point of sliding up the plane. Okay, so that means this motion is going to be upwards. And because the motion is going to be upwards, there and there's friction, the resistance force will act downwards, and we label the resistance force as Fr. But there will be no motion because it is on the point of sliding up. It has not slid up. It is on the point of sliding up. It will not go up. That is because Fr will just manage to stop it from moving up. So now first let's see what is the case with the 65 Newton force acting at 36 degree. So now because of this, one force will act to the right and one force will act upwards. Now let me erase this M12 kg. Now this arrow, I will transfer it here. So it will look something like this. Yes. And now I'll make the diagram again. So this is 90 degree, this is 36 degree. So this is technically a 90-degree triangle. So this will be 90 degree. Then this is 36 degree. 65 Newton is this arrow, which is the hypotenuse arrow. So this is 65 Newton. One force is acting up, one force will act to the right. Okay, so let me use some other color. So this will be X, this will be Y. So now let's use trigonometry. So this is the opposite side. This is the adjacent side. And this is the hypotenuse side. Now let me erase all the arrows. Yeah. So now we can use trigonometry because opposite relates with sine. Sine theta is opposite upon hypotenuse. So similarly, sine 36 will be equal to opposite, which is x, hypotenuse, which is 65. Now this 65 will go up and it will become 65 sine 36 is equal to x. So now x is 65 sine 36. Now let's talk about y. Y is the adjacent side, so we can use cos. So cos 36 is equal to y upon 65. Now this 65 will go up again. So we'll get 65 cos 36 is equal to y. Now we know x and y. So let's write it down here. So if I erase all of this, the arrow to the right, y is equal to 65 cos 36. So this will be equal to 65. Well, let me use another pen. Yeah, orange pink. 65 cos 36. And one force will act upwards. 1 second. The force that will act upwards is this X force. And what is this X? X is 65 sine 36. So this force is 65 sine 36. Now, what more? Yeah, this weight will also act now. It will act across, 1 second. Yes, one force will act across the slope and one force will act perpendicular to the slope. So across the slope will be mg sine theta. So m is mass is 12, g is 10, and theta is 24. So 120 sine 24. and this is mg cos theta. The force perpendicular to the plane is mg cos theta. So this will be 12 into 10 into cos 24. So this is 120 cos 24. So yeah, we are done with this. Now we have all the forces labeled and we know that the resultant force is equal to 0. So what is the resultant force exactly? The resultant force, because the block is about to move up the plane, the motion is in upwards direction. Even though it is not moving, it is about to. So this will be considered positive direction and this will be considered negative. So the positive is 65 cos 36 will be minus 120 sin 24 minus FR. So these three, so this is the first force that is acting to the right. This is the second force. This is the third force. Now, if resultant is 0, here we know that already. So we can say that 0 is equal to 65 cos 36 minus 120 sin 24 minus FR. Now this FR will go to the other side. So it will become plus FR. So FR is equal to this much. And now what is this FR? This FR is nothing but coefficient of friction into R. And what is this R? This R is the contact force. And what is the contact force? The contact force is this R. So now the contact force R plus 65 sin 36 will equal 120 cos 24 because all of these are in the same direction. Two forces are upwards like this, the other force is downwards. So everything will equal. Why? Because the system is in equilibrium and the resultant force should be 0. So let me write that down. R plus 65 sin 36 should be equal to 120 cos 24. Is it 120 cos 24? Yeah. So R is equal to 120 cos 24 minus 65 sin 36. Therefore, the value of R will be, if I put this in the calculator, 120 cos 24 minus 65 sin 36. So the value is 71.42 Newton. So therefore, FR will be U into 71.42 Newton. So we'll put the value of FR here. So 71.42 U is equal to 65 cos 36 minus 120 sin 24. So this 71.42 will go down here and upon 71.42. So if I put this in the calculator, 65 cos 36 minus 120 sin 24 upon 71.4, no, 71.42 upon 71.42. So the value for the coefficient of friction is 0.0529. So value for the coefficient of friction is 0.0529. Now we are done with this question. I don't think it was this difficult. We easily got 6 marks right here. Now we'll go to the sixth question. Oh, we had one more page. Wow. Sixth question. A car of mass 900 kg moving up a hill at an angle. Okay, let's start drawing. As soon as we see horizontal road, inclined hill, we should start making the diagram. So this is the diagram right here. Car. Let's draw the car. the mass of the car is 900 kg. That means the weight will be 900 into 10 because weight is mg, which is 9,000 Newton. And weight due to and force due to the weight always acts downwards. So this will be 9,000 Newton. Inclined at an angle of sine inverse of 0.12. This is sine inverse of 0.12. So this is done. This is done. The initial speed of the car is 11 meter per second. Now it is moving up a hill. So we have to draw something like this. And the speed will be 11 meter per second. And what will be the speed? The initial velocity u. After 12 seconds, the car has traveled 150 meter up the hill. Okay. So that means when time is 12 seconds, the distance or the displacement covered is 150 meter and the new velocity is 16 meter per second. These are three major points that we got here. 1 second, I'll have to write it neatly. I can write it one by one actually down. So it will be like when time is 12 seconds, the displacement is 150 meter and the new speed will be 16 meter per second. The engine of the car is working at a constant rate of 24 kilowatt. Okay, so the power is 24,000 watt. Now what you need to understand is because this engine is exerting power, that means because engine is doing work, that means the engine will be exerting a force, right? Because there is some power that is exerted by the engine, hence there will be some force, and we will call that force FD, which is the driving force. Okay. So now what we have to do is we have to find the work done against against the resistive forces during the 12 seconds. So what we can do is we can use the work energy equation, and that is work done by driving force is equal to delta K, that is change in kinetic energy plus change in gravitational potential energy plus work done against resistive forces. So now what is the work done by driving force? So we know that the power exerted by the engine is this much. Let me label it as PE. We also know that power is equal to work done upon time. So power of engine will be work done by driving force upon time. Therefore, power of engine is 24,000 watt, not 240,000, 24,000. So power of engine is work done by driving force, you have to find out. And we know that the time taken is 12 seconds. So this will go up. And what we will have is 24,000 into 12 is equal to work done by driving force. So the work done by driving force will be, if I put this in the calculator, 24,000 into 12. That is 2,88,000. 2,88,000 joule. So now we know the work done by driving force, that is 2,88,000 joule is equal to delta Ke. Ke is the change in kinetic energy. So how will we find delta Ke now? Delta Ke is nothing but final Ke minus initial Ke. And what is the formula for Ke? Kinetic energy is half mv square. So the change in kinetic energy is half into mass. Mass, what is the mass of the car? 900. And what is the final velocity of the car? Here we just wrote down the final velocity is 16 meter per second. So 16 square minus half into 900 into, and what is the initial velocity? We know that the initial velocity is 11 meter per second. Now if I put this in the calculator, I will get 16 square minus this is upon 60750 joule. So 60750 joule. So that means the change in kinetic energy is 60750 plus delta Gp plus work done against resistive forces. Now let's talk about Gp. So as we know that up this hill, the angle is sine inverse of 0.12. And the distance traveled is 150 meter. And 150 meter up the hill. That means from here to here. This distance will be 150 meter. So this is 150 meter. And this will be the height. So we can use trigonometry. This is opposite. So sine inverse of 0.12 is equal to height upon 150. Now this 150 can go there. So we will get 150 sine inverse of 0.12. So this is the height. Now what is delta Gp? Delta Gp will be mgh. So 288,000 equals 60750 plus delta Gp will be mass is 900, gravity is 10, and height is 150 sine inverse of 0.12. And plus work done against resistive forces. Now what do you have to, we have to find out work done against resistive forces only. So now we have all numbers here, number, and the only variable is work done against resistive forces. So we are up on our last step. So work done against resistive forces will be, I'll transfer this here, which will give me 288,000 minus 60750 minus 9,000. This 900 into 10 became 9,000 into 150 sine inverse of 0.12. One, this bracket closed, now this bracket, now this bracket, now this bracket. Haha. 4 brackets. No, that's 1, 2. Yeah, 4 brackets. So now if you put this in the calculator, we'll get work done against resistive force. And let me put that 288,000 minus 60750 minus 9,000 bracket 150 into sine inverse of 0.12. So the answer is 65250 joule. That means the work done, what have they asked? Find the work done against resistance. So here is our answer. Let's move to the next question. The car then travels along a straight horizontal road. The car then travels along a straight horizontal road. Let's start making the diagram. This is a straight horizontal road. This is a car of mass 900 kg. The resistance to the motion of the car is 1520 plus 4V. So resistance, we'll write it in red resistance. That is 1520 plus 4V. When the speed of the car is V, okay. The car then travels at a constant speed, okay. So now that we know that if constant speed is there, that means acceleration will be equal to 0. And if acceleration is equal to 0, the other thing we know about acceleration is resultant force is mass into acceleration. So if acceleration is 0, if we input this as 0, then we'll get the resultant force as 0. And that means that there is no net force acting on the object. So this is an important thing to mention here. And whenever any question includes constant speed, that is what you have to understand. Then car travels at a constant speed with the engine working at a rate of 32 kilowatt. So engine will work at a rate of 32 kilowatt. That means the power will be 32,000 watt. Find the speed. Okay, so we have to find the speed. So first of all, we'll have to write down what is the resultant force composed of. So one is this force, and because there is power, because the engine is working at a rate of 32 kilowatt, because the engine is exerting power, that means there will be some force, because if it is doing some work, it is exerting some power, that means it is applying a force, right? So that force that will be applied to the engine will be driving force, FD, and that will be against the resistance force. So FD will act, and is there any other force? No. So these two are the only forces. So resultant force will be equal to FD minus 1520. This will be in bracket plus 4V. Now we know that F resultant is 0. So instead of this F resultant here, what I can include is 0. And now I know, we also know that power is equal to force into velocity. So power is the power of engine and force is the driving force. So what is the power of engine? The power of engine we wrote right here is 32,000 watt. So power of engine is 32,000. Driving force we have to find out. And velocity. Do we know the velocity? No, we just know it travels at constant velocity. But what is that velocity? We do not know. So therefore, the driving force will include 32,000 upon velocity. So now instead of the driving force here, I will write this 32,000 upon V. So 0 equals 32,000 upon V minus 1520 plus 4V. And now we'll take this here. So we'll get, no, we won't take this here. We will take this there. We'll get 1520 plus 4V is equal to 32,000 upon V. And now this V will go there, which becomes V bracket 1520 plus 4V. And we can remove this now. Therefore, 1520V plus 4V square is equal to 32000. Now, final step, 4V square plus, 1 second, 4V square plus 1520V minus 32,000 is equal to 0. So if I put that in my calculator, 41520 minus 32,000, the answer will be 20. So V is equal to 20 meter per second, or V is equal to minus 400 meter per second. There are two possible answers because this is a quadratic equation. So now which do we select? Because we have to find the speed, and the speed is moving in the direction to the right, and we have taken right as positive. Your FD we considered positive, right? And this we considered negative. So because it is moving to the right, we only consider the positive answer, because we know that it is moving to the right. Because this minus 400 means the car will be moving to the left. If driving force is to the right, so the car can't move to the left. So the final answer is 20 meter per second. So this is the answer. Let's move to the seventh question. A particle P moves in a straight line. The velocity v meter per second at time is given by this is this. Okay. Show that there is an instantaneous change in acceleration of the particle at t equals 10. So what you have to find is the instantaneous change in the acceleration. So in order to find the instantaneous change in acceleration, first we'll from the velocity time graph, we will have to find the acceleration time graph. And for that, we will derivate the equation. So the velocity is 0.5t. So the acceleration will be the derivative of 0.5t, which is 0.5. So acceleration equals 0.5 meter per second square for time between 0 to 10 seconds. Similarly, we'll find for this one v equals 0.25t square minus 80 plus 60. So we'll derivate this again to find the acceleration, which is the derivation of 0.25t square minus 80 plus 60. So the acceleration will be 2 into 0.25t minus 8. So the acceleration is 0.5t minus 8. Now we can put t equals 10 here. And what we'll get is a 0.5. This is looking like 10.5 seconds. This should be a equals 10 seconds. 0.5 into 10 minus 8. So a will be 5 minus 8, which is 3 meter per second square. So that means using this equation, the acceleration at 10 second is equal to 0.5 meter per second square. And using this equation, the acceleration at 10 seconds is equal to minus 3 meter per second square. I did not write minus here. Yeah, minus 3 meter per second square. So hence we can say that there is instantaneous change in acceleration. Now moving to the B part, find the total distance covered by P in the interval 0 to 20. So total distance covered by P in the interval 0 to 20. So now if we want to go from velocity time graph to distance time graph, then what we'll do is we'll integrate. I did a very minute error here. It should not be displacement time, it should be displacement time. So the velocity is 0.5t. V is equal to 0.5t. And for the other one, the V will be 0.25t square minus 80 plus 60. So this will be minus 80 plus 60. Is it 60? Yeah. So let us integrate this. Integral of v dt will be equal to displacement, which is integral of 0.5t dt. And what will be the limits? For the first one, the time is 0 to 10. So the limits will be 0 to 10. So 10, 0, 10, 0. Now if we integrate this, this will become 0.5. 1 second. This will become 0.5 t square upon 2. And now this will be 10 and 0. Similarly, for this one, the displacement will be integral of v dt. This is 20 and this is 10. So the limits are 20 and 10. Why? Because here the limits are 20 and 10. So the next will be, we will integrate this to get 0.25t square minus 80 plus 60. And this will be 20 and this will be 10. Now first, before going forward, let us make the diagram for the velocity time graph. So how will the diagram for the velocity time graph look like? So first for 10 seconds, the velocity is 0.5t. So at t equals 0, the velocity will be 0.5 into 0, which is 0 meter per second. So the graph will start from here at this point, and now at time 10 seconds, v equals 0.5 t. At time 10 seconds, we will get 0.5 into 10, which is 5 meter per second. So this is 10 seconds. We will get 5 meter per second. Now let's find out that velocity is 0.25 t square minus 8t plus 60. Now when does the velocity become 0? Let's find out. Now if I put this in the calculator, so what I'll get is 0.25, 1 second, 0.25 minus 8, 60, so 20 and 12. So that means the velocity becomes 0 at 20 here and at 12 somewhere here. That means the graph will look something like this. So now what this means is we can't have the limits of 20 and 10. So what limits do we need to have here? This is correct. The limit should be between 0 to 10. The next limit should be between 12 to 10. So this should be 12. And then now let me erase this. This will be the first limit. This will be the second limit of 12 and 10. And the third limit will be the displacement should be the integral of 20 and 12 v dt is equal to integral of 20, 12, 0.25 t square. Oh, I did not mention dt here. Minus 80 plus 60 dt. So that means if let us open this here. So 0.25 t square will become 0.25 t cube upon 3. Minus 80 became minus 80 square upon 2. Plus 60 becomes plus 60t. Yeah. And the limits will be 12 and 10. Similarly, because these are the same, so this will have the same integral, but the limits will be different. 0.25 t cube upon 3 minus 80 square upon 2, which is technically 4, plus 60t, 20 and 12. So now here, the value which I'll get. Now first let me find the displacement for this one. So 0.5 t square upon 2. So 1 second. 0.5 t square upon 2. If I use 10, then I'll get 25. And if I use 0, then I'll get 0. So this displacement is 25 meters. Now talking about this one. So 0.25 t cube. 1 second. I'll have to write that down. 0.25 t cube upon 3 minus 80 square upon 2 plus 60x plus 6080. Now if I input 12, the answer is 288 minus, and if I input 10, the answer is 850 by 3. So this will be 288 minus 850 by 3, which is 14 upon 3 meter. Now talking about this one, if the limits is 20, then answer is 800 upon 3. If the limit is 12, then the answer is 288. So 800 minus 288. So the answer for this one is 800 upon 3 minus 288, which is minus 64 upon 3. Now I need you to realize, why did we get a negative answer? here between limits 20 and 12. So between 20 and 12, the area under the graph will be negative. Why? Because this height here somewhere will be -3 or something like that. That we are not concerned about. But because this is negative, after we did integration, the area we got was minus what was it? -64/3. This area was -64/3. But we have to find the total distance covered. So we will not consider this as negative. We will consider this as positive. We will consider this as positive. So now the total distance will be 25, which is this 25 plus this second 14/3 plus this third one, but we will use a 64 plus 64/3 because this negative area means that it has traveled in the opposite direction. But but that only matters in displacement. Right now, what we have to find is distance. So if it moves to the right, if it moves to the left, if it moves up, down, diagonally, anywhere, we will consider it as positive. So now if I put this in the calculator, 25 plus 14/3 plus 64/3. So the value is 51. That means the total distance traveled is 41 meter. And oh, we are done with this question and we are also done with this paper. Thanks for watching.